we are provided with some logic gates here, and if we write down the Boolean algebra, then we may find the answer. Well, the question here it is, truth table for the logic gates shown in figure is, if this being A here and this being B, at this point I would write down the output Y to be equal to A plus B, and it is actually NOR gate, and this one is A plus B and this is OR gate. These two were NANDed here, so effectively it will A plus B plus A plus B bar. Whatever be the value of A and B, as long as both A and B or any one of them is on its high value, we shall be getting the high value as the answer. And if both of A and B are 0, then this portion will lead us to answer 1. So I would say irrespective of the value of A and B, we shall always have the high value as the output. So for question number 6, option 4 is the correct answer. Now let's proceed to question number 7. Here in question number 7, in a YDS experiment, separation between slits is D, screen is the distance D from slits, and lambda is the wavelength of light used. If intensity of light from each slit on the screen is I0, then minimum separation between 2 points on the screen where intensity is 3I0. It's been given that if these two sources having the intensity I0, we know that intensity being the function of the square of the amplitude, so we may say the A0 square will directly be proportional to I0. Now at this point we shall have the maximum intensity of 4I0, that is the maxima, and the fringe width that will come out to be in this situation is simply delta W is equal to lambda D by D. So from here to here, actual part difference will be how much? It is of lambda and phase difference of 2 pi. We need to find out the position where actually the intensity would be 3I0. So if resulting intensity at this point is 3I0, I shall simply say it is 3I0, or A0 square would be equal to A0 square plus A0 square plus 2A0 square cos phi. Cos phi would be the phase difference, or it is A0 square would be equal to 2A0 square cos phi, or cos phi is coming out to be 1 by 2. 1 by 2 means pi by 3. So this is the phase difference. Now if this being the phase difference, so definitely on one side and on the other side, here we shall have the intensity of 3I0 and here we shall have the intensity of 3I0. So effectively this phase difference is how much? Pi by 3. So, and this being pi by 3, so effectively from here to here it is the phase difference of 2 pi by 3. Having the phase difference of 2 pi, we were having the distance from here to here as 1 fringe width. So having a phase difference of 2 pi by 3, we shall simply have the distance of lambda D divided by D and 1/3 of this fringe width. I guess you got the logic here, isn't that? 2 pi of phase difference, we shall have the distance to be equal to 1 fringe width. So here we got the answer of the 2 point where the phase difference was 2 pi by 3. So simply the distance between those of the 2 points will be 1/3 of the fringe width. So for question number 7, option 2 is the correct answer. Now let's proceed to question number 8. Here in question number 8, a soap film of thickness T is illuminated by white light incident at an angle theta. The refractive index of the soap solution is mu. The wavelength of high intensity light reflected from the film is lambda. Minimum value of T required for this to happen is, we need to find the minimum width of this soap solution so that we shall get the maximum along the reflected side. Well, a bit of classic questions and it requires a bit of calculation here. This is the incident light, I would say. It gets refracted along this direction. Once again it reflects and finally it comes along this direction. This is the reflected wavefront. So if these 2 points would be matching in such a way that the path difference minimum, or in fact optical path difference from here to here, is exactly happens to be equal to the optical path difference from here to here. Then only we shall be getting the maxima in reflected side. This angle being theta, here it is r, it's been said to be t. So first I will be calculating this path difference. So this is delta x1 I'm saying. Let us say this portion being x1. So clearly from here it is 1 sine theta is equal to mu sine r, or sine r will be sine theta divided by mu. So if this is r, this is sine theta, this is mu, this is root under mu square minus sine square theta. That is the ratio for the r here. For this triangular part, I would say cos of r is equal to t divided by x1, or x1 is equal to t divided by cos of r, this x1. So total optical path delta x1 from here to here, it is 2t divided by cos r into mu, mu being the refractive index. Now we need to find this path difference. For it we'll be calculating this distance and this distance first. So let this distance is z1 here. So now I would say tan of r to be equal to z1 divided by t, or z1 is equal to t tan r, this distance. So from here to here, let this one being z. So clearly z will be twice of z1, it is 2t tan r. We got this much. Now for this portion, this angle being theta, this is 90 minus theta. So clearly this is delta x2 from here to here. It is z sine of theta. It is 2t tan r into sine of theta. Apart from this distance, this wave, once it was reflecting from this surface, it actually beared some extra phase of pi. So what we have here, the effective path difference from here to here, that happened to be 2 mu t divided by cos of r. It must be equal to 2t tan of r sine of theta plus lambda by 2. This lambda by 2 additional part difference is because of the phase shifting here. Once we try to solve this equation and we try to find the value of t, we shall be getting the value of t that will be equal to lambda divided by 4 square root of mu square minus sine square theta. I expect you to calculate this answer from here. So looking onto the option for question number 8, option 1 is the correct answer. Now let's proceed to question number 9. For a particular medium surrounded by air, critical angle for total internal reflection is theta c, and polarizing angle is found to be theta p. Relation between theta p and theta c is easiest of the question here. If this is the denser medium mu and this is the lighter medium, that's air, its refractive index being 1. If this is the critical angle, it would simply be mu sine of theta c would be equal to 1, or sine theta c would be 1 by mu. Now if the radiation comes from this side and if refracted on this side, and for that condition the angle of the polarization that's been given to be tan of theta p, we know that it will be coming out to be mu here. So on that case we already had the answer for mu to be equal to 1 by sine theta c. I can write it down as cot of theta p would be equal to 1 by mu, that is sine of theta c, or theta p can be taken as cot inverse sine of theta c. Well, this is the answer for question number 9, that is option 3 is the correct answer. Now let's see the question number 10. Here in question number 10, 70% of a radioactive sample is left undecayed after time t0. The percentage of initial sample which will decay in total time of 3 t0 is. We know the law of radioactive decay, that N is equal to N naught E minus lambda T. This part will actually tell you about the total active nuclei at any time. This was the active nuclei initially. So it's been said 70% of the radioactive sample is left undecayed. That means there is a number that is still remaining. So in one time, I would say 7 by 10 N naught, that's remaining. N naught E minus how much? Lambda T naught. So in one time T naught, 70% is remaining. In next time T naught, I would say 7 by 10 N naught into again 70% of that would be remaining. And in next further T naught time, again its 70% would be remaining. So this is the remaining portion. Initial number was how much? It was N naught. We need to find the percentage of initial sample which will decay. So total number that must have decayed is N naught minus N naught. 7 into 7 into 7, it is 343 divided by 1000 divided by N naught into 100. This is the percentage of the numbers that must have decayed. So 1000 minus 343, it will come out to be 657 divided by 1000 into 100. On calculation, we shall be getting this answer to be 65.7%. So for question number 10, option 1 is the correct answer. Now we shall proceed to question number 11.